Hello guys, welcome to this phenomenal experience. It's neurophysiology series by me. I'm Charlie, the anchor and the presider for this course. This video contains everything you need to know as a medical student in neurophysiology. It contains the basic things that you are supposed to know in neurophysiology. The course is a very interesting one and very broad as well. Okay, going forward, I have structured everything we'll be discussing in this class or in this course into modules, beginning with module 1. So in module 1, I'm going to introduce neurophysiology. What is it about? In module 2, we'll look at the hemispherical specialization, the right and the left hemispheres and their various physiological functions in humans. In module 3, we shall be looking at the tracts of the CNS. The CNS has many tracts which carries information to the brain and also carries motor command back to our body parts for responses. Alright, so we'll look at all of that in module 3. In module 4, we'll be looking at ANS physiology. ANS simply means the autonomic nervous system. Alright, very important aspect of physiology. I guess you don't want to miss this part. Alright, we'll look at this ANS physiology, everything concerning it in module 4. In module 5, we shall be discussing spinal reflexes, the reflex arc, the components of the reflex arcs, the types of spinal reflexes such as the stress reflex, the withdrawal reflex, and so on and so forth. Reflexes are very important to humans because they help us to overcome gravity. Alright, we shall look at all of that in module 5. Okay, alright, in module 6, we'll be discussing pain physiology. Pain is a very important component of human existence. It is the only stimulus that drives a lot of people to the hospital to meet with a doctor. Alright, so as students who are aspiring to become professional medics, pain physiology is one topic in neurophysiology that you should not miss. Alright, we'll look at all of that in module 6. In module 7, we'll look at nerve physiology, the neurons, components of the neurons, the transmission of action potentials through the neurons. Alright, and lastly, in module 8, we shall be discussing the nervous homeostasis in health and in diseases. Okay, so we'll look at all the diseases associated with the brain, the nerves, the spinal cord, and how they could be managed. Alright, this is just one aspect of physiology, neurophysiology. You see, neurophysiology is very broad, but it's also very interesting. Alright, so I did not include physiology of motion in the topic straight here, but we are going to do that in neurophysiology too. Alright, the physiology of motion, that is another aspect of physiology, neurophysiology, that you need to understand as a medical student. Fantastic. Going forward, we will now look at module 1, the introduction to neurophysiology. We'll look at the general plan of the nervous system, the meaning of neurophysiology, the functional anatomy of the brain. Okay, general plan of the nervous system. The nervous system is actually divided into two basic parts, the CNS and the PNS. CNS means central nervous system, while the PNS means peripheral nervous system. Please make sure you are writing. Okay, the CNS is divided into two parts, the brain and the spinal cord, whereas the PNS is divided into two main parts, the efferent nervous system, efferent neuron, also known as the motor neuron, and the afferent neuron, which is also called sensory neuron. The efferent or motor part of the PNS is subdivided into two major parts. The first part means the autonomic nervous system, and the second part is the somatic nervous system. The autonomic nervous system plays a major role in controlling involuntary movements. Okay? While that of somatic nervous system controls voluntary movements, such as movements of the skeletal muscles. ANS is subdivided into three major parts. The first one is the parasympathetic nervous system. The second one is the sympathetic nervous system. And the third one is the enteric nervous system. This part of the ANS controls the GIT, movements in the gut. Look at all of this as we proceed in this class. Okay, going forward, what is neurophysiology? The aspect of physiology that is concerned with the structures, functions of the brain, the spinal cord, and nerves or the neuron is known as neurophysiology. Okay, it also deals with how the structures interact with each other to human behaviors or to bring about bodily functions such as movements, writing, emotions, speech and language, learning and memory, sleep and alertness, and also recognition of faces and objects. Oh, this is what neurophysiology is all about. Okay? Now, movement is controlled by the nervous system. You see, when you get up to move, there are structures in the brain controlling every move or movement you make as a human being. It is not the dibia in your community that is doing that, but structures in the brain. Alright? So these things are in neurophysiology. Is an aspect of neurophysiology known as physiology of motion. Okay? We are going to do that in neurophysiology too. Also, writing is a kind of movement known as skilled movement. You see, when you pick up your pen to write, you are not just doing that on your own. There are structures in the brain that is controlling movement of the hand, first grasping of the pen between the fingers. This is a pen. There are structures that controls the grasping of this pen between your fingers, and then the movement of your hand to write whatever I'm teaching you now. Okay? Writing is a kind of movement known as skilled movement. Okay. This is controlled by structures found in the human brain. Right? Also, emotions is a very important aspect of human life. Every emotion is controlled by the nervous system, such as feeling of joy, sadness, anger, fear. All these are emotions, and there are structures in the human brain that controls emotions. Also, falling in love. When you fall in love with a person, it is not your heart. My goodness, it is not your heart that is falling in love. There are structures in the brain that is actually making you to like a person or even hate a person, not the heart. So you cannot tell me that your heart is beating faster. It should be your brain. Your brain is beating, is beating or working or thinking about a person, especially the limbic system in humans. Every emotion. All right. Talking about speech and language. Speech is also controlled by structures found in the human brain, the Broca's area, the Wernicke's area, and so on and so forth. As I'm teaching you now, I am not just producing these words by my own power or by the oracle in my village. No. It is the structures in my brain that are controlling movement of the muscles of my lips and my tongues to produce the words. Alright? So, speech is also controlled by structures in the brain. When you talk about learning and memory, you want to be very intelligent, you want to improve your memory capacity, It is all found in neurophysiology. And that is why, as a student, you need to understand that neurophysiology is a course you must do, and not just do it well, but understand everything in neurophysiology, how the structures in the brain affects you and helps you to create your behaviors. All these things are in neurophysiology. You want to be very, very intelligent? Come, study neurophysiology. All right? I can tell you, you'll be very, very brilliant. Okay? We talk of sleep and alertness. You don't just go to bed to sleep. No, there are structures in the brain that controls wakefulness and sleep. All right? That structure is known as the reticular formation. We'll look at all of that in this class. Recognition of faces and objects and even moods. If, for example, you can see my face, you can recognize that this person is Mr. Charlie. Yes. If you see a pulse, you know that, oh, this person is a pulse. And you think it's by your power? No, that is not by your power. They are controlled by structures in the brain. You are able to recognize the faces of everybody you see. You are able to know when a person, you are able to recognize when a person is happy or when a person is sad through the face, recognition of faces. You're able to recognize that this is a pen. You're able to recognize that this is a mic. You're able to recognize that I'm putting on a yellow t-shirt. These things are regulated and controlled by structures in the human brain. Okay, so neurophysiology, in concert with the endocrine system, helps to create all human behavior, helps us to regulate all human bodily functions. There are two aspects of physiology you must know very well in medical school. One is neurophysiology, the second one is endocrine physiology. Very important. All right, going forward. The nervous system is made up of neurons, that is nerve cells that transmit signals or messages throughout the body. Okay? It also contains dendrites. The nervous system also has dendrites. There's short processes of a neuron. It also has axons, which are the long processes of nerve cells. All right, there are also axon terminals, that is found in every nerve. Okay, it also have neurotransmitters, that is chemicals which are stored at the axon terminals of each neuron. Okay, and synapse. Okay, the junction between two or more neurons is known as synapse. Okay, we'll look at that in this class when we discuss nerve cells or nerve physiology. And there are also receptor sites which carry stimulus from the neurons to the higher centers and then back to the effective. Alright? Good. Brain and function. The brain is the most complex organ in the human body. Alright? It contains billions of neurons that interact with each other or one another to create human behavior. Understanding brain structure and function has been made very easy and available through the use of PET scan. PET scan simply means positron emission tomography. That's the meaning. Okay, another way scientists use this to understand the structures in the brain and how they function is through the MRI. MRI simply means the magnetic resonance. Okay, and they also use EEG, which means electroencephalogram. Okay, we'll look at all of that as we proceed. Brain sizes and intelligence. Here we want to look at the correlation between intelligence and the brain sizes. Okay, good. Now, a normal human male has a brain weight of about 1,400 grams. In females, the brain weight is about 1,300 grams. It means that the males have higher brain weights than females. Okay? Now, there are 3 living species with brain weights larger than humans. These species are the porpoise. The porpoise brain weight falls between 3,500 to 4,000 grams. That is massive. Another species that has brain weights higher than human beings is the elephants. And their brain weight falls between 4,000 to 7,000 grams, followed by the whales. which also falls between 4,000 to 7,000 grams. These animals have very large brain weights. Okay? Now, there have been conflicting reports by scholars and researchers about brain sizes and intelligence. In some reports, the scholars has postulated that people with higher brain weights are more intelligent than people with lower brain weights. For example, these three animals have higher brain weights than human beings. It simply means that what that report was saying is that the porpoise, the elephants, and the whales are more intelligent than humans because they have large brain sizes than human beings. Let's say in a class of OPT, the males have higher brain weights than females, all right? Then the reports is simply saying that the males in optometry class 300 level are more intelligent than the girls in the same class. Or generally, you could say because males have higher brain weights than females, they are more intelligent than girls. But thinking about this, is that right? We'll find out. Another report postulated that people with smaller brain weights are more brilliant and smarter and intelligent than people with larger brain weights. These are conflicting reports. In the report of that scholar, it simply means that because girls or females have lower brain weights than males, and than these animals that I have listed here, then females are more smarter and intelligent than males. That is that report saying. So actually conflicting. Now, coming to think of this, the porpoise, the elephants, and the whales, they have very massive brain weights. But are animals intelligent than human beings? Do you think that the elephant is more intelligent and smarter than humans? Well, for me, the answer is no. Because human beings are the most intelligent species or living thing on Earth. Alright? So this report should be, abolished. Because there is no way you can correlate brain sizes and intelligence. Okay? Alright. Good. Now, you cannot tell me that people with Ishi Bambi, very big heads, are doing better in your class than those ones with smaller heads. That is not true. And you cannot tell me that because males have larger brain sizes or they have big heads, then they are more intelligent than the females in their class. No, that is not true. In the same way, you cannot tell me that females, that is following these reports, that females who have smaller brains or smaller heads in a class are more intelligent than the ones with very big headboard. Alright, no. That is not true. But then, what makes humans or what makes people intelligent and smarter than animals? Now, what makes humans more intelligent or smarter than animals? And what are the criteria for determining intelligence? Alright? I believe every human being is intelligent and smarter than animals, no matter the size or the weights of the brains of these animals. Okay? Let's find out as we proceed. Okay. Human beings are more smarter and brilliant than other living species, not because of their brain weights, but because of the presence of one, association areas. The human brain consists of so many association areas, which makes them more smarter and intelligent than animals. The association areas also helps human beings to do a lot of things that animals cannot do. Like, for example, language and communication is the highest function of the human mind. Speaking. Do you know that human beings can speak the language of every other animals on earth, whereas there is not even one animal that can make the sound or speak the language of a human being. All right. If, for example, I ask you to make the sound of a cat, yes, of course you can make that sound. Yes. Okay, make the sound of a dog. All right. Make the sound of a goat. You. Okay. Now imagine you came back home from school, and the next thing you saw was your dog singing, Obina, come. Aren't you going to run away? Of course you will. In fact, I will even help you to run. I will help you to do the running. Because it's not possible. There is not one animal that can speak language. It's even difficult to say come. Not even the parrot. Can the parrot speak? No. The answer is no. A parrot cannot speak the language of human beings. These things makes human beings more intelligent than animals, because the association areas are well developed. These structures are well developed in human beings than in animals. Another thing that makes human beings more smarter, more intelligent than animals is the convolutions or cortical folding. Now, if you look at the brain, you find out that there are foldings. Okay, something like okay, I will show you a picture of the brain when we proceed. Those foldings are convolutions. They are grooves and gyri that helps to expand the surface area of the brain, helping us to accommodate more information. These areas receives signals in temporal regions of motor and sensory cortices, as well as from the subcortical structures. The association areas are not found in animals. They are not well developed. All right. Now, the most important association areas include one, the parieto-occipital temporal association area. Please, this is parieto-occipital. Okay, this dash is supposed to be here. Is a typographical error, so take notes. Parieto-occipital temporal association area. Okay. The second association area is the prefrontal association area, and then we have the limbic association area. These are the three main types of association areas. Okay, now the parieto-occipital temporal association area makes analysis of the spatial coordinates of the body. These are the specific functions of this area. Where is it found? Where is the human mind? Is it in the chest or the head? All right, go and find out. This area are also responsible for language comprehension. Okay, it also initiates processing of visual language, like reading. You could read what is written on this slide. That is visual language, and it is controlled by parieto-occipital temporal association area. Okay, call your dog to come and read this thing. Can they? Can the dog read it? No. Call an elephant to come and read it. Can the elephant do that? No. Only human beings can do this. Alright? This area also helps us to name objects. Like if you see a pen, you know that, oh, this is a pen. You see a cap, you say, that is a cap. Alright? Naming of objects are found in this area. Going forward, these association areas are very vital in language and communication functions. So in speech and communication, the association areas plays a vital role. Okay, for example, the Broca's area is specific for word formation, speech production. Like as I'm producing the speech, this Broca's area is very active right now. So it is the one helping me to make or form these words that I'm voicing out. Alright, and then there is Wernicke's area. This area is very important for word comprehension. So as I'm teaching you, you can hear me and you can understand what I'm saying. It is not controlled by the Dibia or the Babalawo in your community. You are able to understand what I'm saying because of this structure in the brain, the Wernicke's area. It is responsible for what? Speech comprehension. Alright? Good. However, convolutions, like I said earlier, increases the surface area of the brain. Thus, more information can be relayed, can enter into the brain. Alright? Good. Now we shall look at parts of the brain. The human brain has three main parts, which are the forebrain, the midbrain, the hindbrain. The forebrain is made up of the cerebral cortex, the basal ganglia, hippocampus, and the amygdala. Now, it is also made up of the thalamus, and the hypothalamus. Of course, we have the diencephalon and the telencephalon. All these are various parts of the midbrain and the hindbrain. Okay, now the midbrain is made up of the tectum and the tegmentum, whereas the hindbrain is divided into the pons, the cerebellum, and the medulla. Take note that both the midbrain and the hindbrain together form what is known as the brainstem. So the structures forming the brainstem includes the tectum, tegmentum, the pons, the cerebellum, and the medulla. Alright? Good. Alright, we shall now look at the different structures of the brain and how they function, beginning with the cerebral cortex. This is the body's ultimate control and information and processing centers. A lot of things are going on in the cerebral cortex. It's a very powerful aspect of the brain. When we dive into the cerebral cortex, as in properly, you will understand how these parts of the brain are working to create behaviors. Alright? Okay, going forward. The lobes of the cerebral cortex, actually there are 4 main lobes of the cerebral cortex. The first one is the frontal lobe, okay? The second one is the parietal lobe. The third one is the occipital lobe, and the last one is the temporal lobe. Okay, these are the 4 main lobes of the cerebral cortex. The frontal lobe is at the forehead, okay, the top. Look at this man. This is a favor. This is favors, right? And then this is the location of the frontal lobe. This part of the brain, the frontal part of your head, is where the frontal lobe is located. The frontal lobe is also known as the motor cortex. Good. The parietal lobe is at the top and middle area of your head. Alright, this aspect of the head is the parietal lobe. Okay, good. And the occipital lobe is also known as the visual cortex. It is responsible for visual perception. Okay, so for sight, seeing. This is where it is located, just at the back of your head, your ogo. Okay, we call that ogo when we are much younger. Yes, that is where the occipital lobe is located. It is responsible for vision. Okay, good. The parietal lobe is responsible for the sensory cortex, so it receives all sensory information from all your body parts. All right, just to take note of that. Good. And then lastly, we have the temporal lobe, which is just above the ear. This area is the temporal lobe, and it is the auditory cortex. It plays a very vital role in auditory perception and interpretation. Okay, so when you can hear the sound of my voice, these things are going here to the temporal lobe, and then it processes it, and then it tells you exactly what I'm talking about. Alright, going forward. Now, let's look at the specific roles of the cerebral lobe, starting with the frontal lobe. It is involved in planning of movements, every movement you make. Look, it begins with thoughts. Okay, I want to move from this point to that point. It begins with thoughts. Every movement begins with thought generation generated in the mind. All right, these things are planned by the brain, not by the juju in your village. No, by the brain. So planning, decision making, and speech are all functions of the frontal lobe. All right, good. We'll look at this in details as we proceed in this course, neurophysiology. All right, like I said earlier, every sensory information, if for example I pinch you, you feel it. All right, that stimulus is carried by neurons to the parietal lobe. So every stimulus, sensory stimulus, coming from all parts of the body, goes to this part of the brain, the parietal lobe. Okay, now the occipital lobe, like I said earlier, is responsible for vision. Okay, and then the auditory lobe is responsible for hearing everything that has to do with auditory stimulus and perception. Okay, good. Let's go forward. Functions of the cerebral lobes or the cerebral cortex. The frontal lobes are involved in speaking and muscle movements and in the making and planning of judgments. It is the executive. Alright? Go. The parietal lobe is actually responsible for receiving sensory information. Actually, the CNS does three basic things. It receives information from all parts of the body. It processes that information and then it sends down motor commands to the effector organs for responses. These are the three basic things the CNS does. Alright, going forward. Now, the occipital lobe includes the visual areas which receives visual information from the opposite visual fields. Why is it the opposite visual field? Alright, now, there is a way the cerebral cortex functions. It functions differently from the cerebellum. Take note that the cerebral cortex is different from the cerebellar cortex. Okay, now the cerebral cortex controls the opposite side of the body. Okay, now the right cerebral cortex controls the left part of your body, whereas the left cerebral cortex controls the right side of your body. That is how it works. Okay, good. Now, we say this occipital lobe includes the visual areas which receives visual information, stimulus from the opposite visual field. That is from the, if this is the right cerebral occipital lobe, if this is the right occipital lobe, it receives sensory information from the left visual field, the left eye. Okay, goes to every visual information coming to your right eye is received by the left occipital lobe. Every visual stimulus coming to the left eye is received by the right occipital lobe. Okay, that's how it works. Now, the temporal lobes includes the auditory areas, each of which receives auditory information primarily from the opposite ear. All right. The functions of the limbic system and the hypothalamus. Now, the limbic system functions in concert or together with the hypothalamus. You cannot make mention of the limbic system without the hypothalamus. In the same way, you cannot talk about the hypothalamus without talking about the limbic system. All right, good. These are their functions: the hypothalamus, the pituitary, the amygdala, the hippocampus. All these structures deals with basic drives, emotions, and okay. Now, specifically, the hippocampus is the structure of the limbic system. This campus is the structure of the limbic system. This ring-like structure represents the limbic system. All right. So this is one structure component of the limbic system, the hippocampus. This is another structure of the limbic system, component, rather, the amygdala. All right. Hippocampus is specifically important for memory. So everything memory, hippocampus. All right. If you are not able to recall things, it means that your hippocampus or some structures in the limbic system are affected. All right. Good. Going forward, the amygdala is responsible for fear and fight reaction. Now, when you see two people fighting, the amygdala are very, very hyperactive at that point. If, for example, you are maybe going somewhere and you ran into a lion, okay, you ran into Odumeje, who is the lion. You know, Odumeje is the lion. Okay, what happens? The amygdala are immediately activated. You get very scared, fear, and you immediately run away. Okay, that fear reaction is controlled by the limbic system. Okay, now research has proven that if you remove this component of the limbic system, the amygdala, every fear will disappear. For example, if you know a person who is always scared, who is always afraid, just bring that person, let me dissect the brain and remove this component of the limbic system. That person will never be scared of anything again in life. Research has proven that the removal of the amygdala from cats immediately remove the fear from that cat, that it was able to confront a snake. All right, good. So if the amygdala is removed, you'll be able to confront anything. Maybe you are being intimidated by someone in your street. You see the person, every time you get scared when you see the person. If I remove this part, this part of your brain, you will never be scared of that person. You will even stand to fight that person, and you keep fighting that person until you win. Yes. So what am I saying? This structure basically controls fear or fight reaction. There's what we call flight or fight reaction. Flight simply means you are scared. You see something, you get scared, and you run away. And then fight simply means you see that thing, you just stood there, you fought that particular thing rather than running away. Alright? It is controlled by the amygdala, the limbic system. Also, everything that has to do with emotions, anger, fear, love, joy, happiness, sadness, they are all controlled by the limbic system. This is the structure controlling every human emotions, the limbic system. Alright, good. The hypothalamus plays vital role in hunger, thirst, body temperature, pleasure, and also regulates the pituitary gland. Okay, good. Now the hypothalamus has so many functions. It has vegetative and endocrine functions. The hypothalamus, in fact, are responsible for sweating, for cold, for feeling of pleasure, motivation. Everything is there. Hunger, feeding, drinking of water, everything that has to do with human behavior is in the hypothalamus. All right, we are going to look at physiology of the hypothalamus in the subsequent lectures. Okay, going forward. All right, this is the hypothalamus. Like I said earlier on, it lies below the thalamus. Okay, now it controls body temperature, feeling of warmth or cold, body temperature. So when you are cold, the hypothalamus, some structures in the hypothalamus are activated, which regulates that your body temperature to normal. So you begin to feel, you move from being cold to normal again. It also regulates reproduction, okay, through secreting, stimulating the anterior pituitary gland, which makes it to stimulate the gonads to release some reproductive hormones. The hypothalamus plays a vital role in reproduction, in feeding, in drinking, stress, motivation. Basically, it helps to govern the endocrine system via the pituitary gland. It is also linked to emotions. There are some structures in the hypothalamus that is linked to emotions. The limbic system, I have said that earlier on, it has so many components. I've listed a few here. One is the amygdala, the hippocampus, the nucleus accumbens, the cingulate gyrus. All right, these are structures, some structures found in the limbic system, and they help to control emotions, fear, and memories. All right, all of these are controlled by the limbic system. Good. The thalamus, this is the brain sensory switchboard. Every information coming from the body parts to the brain must pass through the thalamus. It is the relay center. Also, every motor command coming from the brain down to your body parts must pass through the thalamus. So it is the body's relay center. Good. The brainstem, like I said earlier on in this class, is formed by the midbrain and the hindbrain. These two structures or parts collectively forms the brainstem. The components include the tectum, tegmentum, reticular formation, pons, medulla, and cerebellum. Alright? Functions of the brainstem. The brainstem houses the respiratory centers. Now you are taking in and breathing out air. There are centers in the brain controlling that. You are doing that by your power. Okay? That center is found in the brainstem. Alright? It also houses the vasomotor center, which controls heart rate, heartbeat, BP. Okay? That center that your heart is beating, you cannot stop it from beating. Okay? So it's involuntary. This structure controls heart rates, BP. It is found in the brainstem. Alright? Good. Now, deglutition center, swallowing, is also controlled by structures in the brainstem. The vomiting center, when you go to throw up, there are structures controlling that. It is found in the brainstem. Okay? Now, there are also some cranial nerve that controls vital structures or functions, and these cranial nerves are located at the brainstem. Okay. I said generally the brainstem is responsible for automatic survival functions. Now, Your heart is beating. Sometimes you're not even aware that your heart is beating because the mind is busy focusing on something else. You might be very busy copying notes, but your heart is beating, you're alive. And you think they're just there beating? No. There are structures in the brain controlling the heartbeat. Heartbeat is not a voluntary action. Can you stop your heart from beating? No. Okay? There is no human being that can stop the heart from beating. It is involuntary. And what we are saying here is that these centers that are found at the brainstem controls all involuntary actions. Okay? Like you could be moving on the streets and admiring a beautiful girl somewhere. You might not know the position of your legs at that particular point in time, right? But your legs are moving. They are changing positions. You could be sitting and watching this video and you don't know the position of your legs. But there are structures in the brain that knows the orientation of your body parts at every given time. Alright? Those things are involuntary actions. Okay? Good. Let's proceed. Now, the reticular formation plays vital role in sleep and alertness. This is the brain switch, reticular formation. So like I told you earlier on in this class, you don't just go to sleep and wake up on your own, accord or control. Yes, you might feel very sleepy, but it is actually the reticular formation that switches off all those active areas in the brain and makes you to go to bed. Okay? Now, in the morning when you want to wake up, it also switches on or turns on vital structures in the brain. This is the reticular formation. Look, the purple colored structure represents the reticular formation. Alright? As you can see from the diagram, it sends collaterals, branches, to every part of your brain. So at night, it's like the switch of the brain. It turns off those areas in the brain and you just sleep. Again, in the morning, it switches on some vital areas in the brain and you just wake up. Sleep and alertness or wakefulness is controlled by this structure, the reticular formation. Alright? Good. So, whenever you find it difficult to sleep, insomnia, like in patients who are sick, who are experiencing maybe severe pains, they cannot sleep at night because these structures are activated, telling the brain that look, something is wrong, and it keeps you awake all through the night. Okay, that is why pain is associated with sleeplessness. If you are having a severe pain, it is very difficult for you to sleep because this structure in the brain will keep you awake. Alright, we'll talk more on that when we get to sleep, pain physiology. Now finally, the cerebellum. The cerebellum is the little brain attached to the back of the brainstem. Alright, this is the cerebellum. Alright, the cerebellum is very important in controlling automatic or involuntary movements. I said perhaps maybe you as a guy or a female, you are walking and admiring a beautiful thing somewhere. Alright? You may not know the position of your leg at that point, but this area of the brain knows. The cerebellum has the picture of all your body parts in space. It helps to modify motor plans generated by the cerebral cortex. Alright, very important in physiology of movements. I'm going to teach you how the cerebellum helps us to make our movements smooth and sweet. All right, good. So actually, it coordinates voluntary movement and balance, but mostly all involuntary um, senses goes to the cerebellum. It can coordinate voluntary movement also and balance because it has the vestibular aspect, that is vestibulocerebellum. It also has the spinocerebellum. There are aspects. These are the components of the cerebellum which plays a vital role in movement. All right. It is also involved in non-verbal learning and memory. The cerebellum and the basal ganglia, all right, they work hand in hand. Now, they play a vital role in modifying motor commands, that is, commands for movements. But they also have other roles, that is, the non-motor functions of the cerebellum. It plays a role in learning and memory, okay, especially when you are trying to acquire new skills. It is the cerebellum that helps you to do that. All right. Now, damage to this part of the brain will lead to difficulty in movement or keeping your balance. All right. So, whenever the cerebellum is damaged, there is always problem with your movement. It may not cause paralysis, but it makes the movement to become so awkward and so abnormal. All right. Now, these functions occurs without any conscious effort. Okay. Go. Oh, we have come to the end of today's lecture. Alright, the quiz for today is very simple. Number one, tabulate each structure of the brain and their functions. Alright. Number two, discuss one, the role of the human brain in producing anger. Alright. These assignments should be submitted before the next class. Alright, I want to look at them and grade you accordingly. Good. Up next is the cerebral hemispheres. Okay, this is not a class that you should miss. In this class, I'll be teaching you the specific roles of the right hemisphere and the left hemisphere and how they help to control handedness. Let's do it again next week. I remain your anchor and presider, Wapo Charles. Thank you for staying tuned. Bye.